Hello. So in the last video, we discussed how using transformations can actually prove that two figures are going to be the same. We can prove that they look alike. They are not only look alike, but they are exactly the same size and shape by those rigid motions. And we described those as being, those transformations were translations, rotations, and reflections, and those three were always going to stay the same shape and size, so they were rigid motions. So in this video, we're going to discuss how the same corresponding parts of congruent triangles or in any figure are going to be congruent. So you'll see here that we have this acronym Cpctc, or we can actually call it Cpctc, which is what we usually call it in the math geometry world. But Cpctc or Cpctc is an acronym for corresponding and we'll talk about what we mean by corresponding here in a moment. But corresponding parts of congruent. So we've done a transformation and we've determined that these two figures are congruent, but we can actually use their parts to determine if they're actually going to be congruent. And then corresponding parts of congruent figures or triangles, we are more specifically going to be talking about triangles in this instance. But this will work for all figures. If you have a trapezoid that has undergone a transformation, and you have the pre-image, which is the image before the transformation, and then you have the image, and you're looking at those two figures, they're going to be congruent because they've undergone that rigid transformation. So let's say that we're looking at two triangles or any two figures and trying to determine if they're congruent. So their corresponding parts are going to be congruent. Okay? So when two figures are congruent, their corresponding parts. Now let's talk about what we mean by corresponding, okay? So if I have a right triangle here, and then I have another right triangle here, so this side is going to be corresponding to this side, okay? And what I mean by that is they are in the same position. So try to think about that as the position, same position. On the figure. If you think back when we talked about corresponding angles, we talked about, we had two parallel lines and a transversal that went between. And we said that if they were corresponding angles, then they were, say, this angle and this angle, because they were in the same position on the figure. Okay, so that's something I want you to remember. But when we're talking about two figures or two triangles that are congruent, the corresponding sides as well as the corresponding angles are going to be congruent every single time, especially if a rigid transformation has occurred. Okay? So let's move on here. So we're gonna go through an example, and then I'm gonna give you an example for yourself. But we have these two triangles, A, B, C, and D, E, F. I want to explain that just this statement alone can tell you some parts that are congruent. So you notice how A is the first letter, and then D is also the first letter. So we will know that A and D, the angles A and D, will be congruent. So that's just a helpful hint to help you along when you're trying to determine if figures are congruent or not. Something that I've always noticed. Okay? So we're saying that these two triangles are congruent. We can't just say that without having a little bit of background. Okay? So how do we know? Well, first off, it tells us that AB is congruent to DE. So this is referring to the sides. So side AB and side DE. Notice how they're in the same position on both of the triangles, okay? So then we have BC is going to be congruent to what? So let's look at BC, and what's going to be the same position on DEF as ABC? And you might be saying that would be EF, okay? So EF is actually going to be the congruent of the corresponding side to BC. Those are corresponding. Now we know that CA, that's the hypotenuse on this triangle, so that means that it's going to be the hypotenuse on this triangle. Those are going to be corresponding parts. And CA is going to be congruent to DF. Okay, so those are all corresponding sides. And now let's talk about the angles. So, like I said before, you can kind of already tell which angles are going to be congruent based off of the way that it's named. So, A is congruent to D. Those angles are congruent. B is going to be congruent to, let's look, B on ABC is a right angle. So the right angle over here is going to be the corresponding angle. So angle B is going to be congruent to angle E. And then last, we have the angles that are not mentioned, which are angle C is congruent to angle F. Okay? And those are all the corresponding angles. Okay, so we know that these two triangles are congruent because their corresponding sides are congruent and their corresponding angles are congruent. And that's exactly what Cpctc means. Okay, the corresponding parts of congruent figures or triangles are congruent. Okay, so I want you to pause this video right here on this example, and I want you to try this example. Figure FGH is congruent to triangle LMN. So we need to complete the congruent statements. So once you've paused it, give yourself some time, do it, and then go back. And I'm going to go through this now to give you the answers for that. So side FG, now the thing about your figures you have to pay attention to is they may be turned a different direction. But FG is actually going to be congruent to ML, or LM in this case. Okay. GH is going to be congruent to MN. And I'm just putting these lines above them to represent that they are sides or lines. Okay. Then NL is going to be congruent to HF. So those are our corresponding sides. And this is one of those things that once you see it, you know it. So now angle F is going to be congruent to angle L. Angle M is going to be congruent to angle G. And angle H is going to be congruent to angle N. And I just represented that using those congruency signs at those angles. So you can always use that to determine if there are two that are congruent. Okay, so this sums up this lesson for Cpctc, and maybe now you can go through the practice and be able to do that before Friday. You guys have a great rest of your week and a great weekend.